Okay. So first and foremost, I wanted to explain all of you the core objective and concepts when it comes to data science. Right? So everyone has the textbook that we are starting with, right? Can anyone tell me the name of the textbook?
Machine learning with using Python.
Correct. Yeah. So the first and foremost, right? Whenever we are trying to learn machine learning, always keep in mind that the core objective of implementing ML is not just to implement something. The core objective always is tied with the type of use case that you are working on. For example, let's say that somebody who is a user and who wants to come on Amazon's website and would like to buy a particular product. Let's say he's trying or she's trying to buy a product like machine learning with using Python, the same textbook you bought. So what he or she is going to do is he'll come on the website, he'll search using certain keywords like machine learning, Python, something like that. And the system has to automatically give certain set of options. So when some system is basically giving you an option, obviously that option will come basis the user, type of user. So now let's say I am the user and this is the first time that I have come. So now the system does not have any existing data about me. What are my patterns? What do I like? It just knows my email ID, maybe my date of birth at max, right? And all those basic details. But it does not know whether I like a particular, product, do I like a particular publisher? It doesn't know anything about it. But let's say that this system, the website, has all the existing information about all those people who have bought similar kind of products. When I say similar kind of products, let's say same text. What are their patterns? What is that they search? How many of them have given positive reviews? How many of them have given negative reviews? What are the total number of pages? What are the type of keywords people have used? Basis all of that, you need to create a mechanism where all those products, here the textbooks, which are sold at max or have the highest sales and people really like it, they have a positive feedback, will typically come at the top. And those who do not have that much visibility will basically come at the bottom when you search something on Amazon.com. Now, this mechanism or framework is called recommendation engine. Right? So your simple example is you go to Prime Video, you have searched some thriller movies or horror movies, and suddenly what will happen is whenever you log in next time, they will give you a recommendation related to what you have seen previously. So now what happens is that, do you think that there is a machine learning here? Now, you can make this entire framework in such a way that basis certain set of keywords, basis certain set of traits, you can just create a rule-based mechanism. If a person of age so and so, searching so and so, and who has XYZ trait, that particular person would end up buying this product. This can be one way. Second way is I create a mechanism where I identify a probability of every person who's entering my system. What is the probability that he or she would end up buying this product? I can deliver that as well. So if I use an existing information, make it in such a way that now my system understands that somebody with certain set of traits come into the system, I should be able to give an outcome to it. Let's say, for example, Hemant, age so and so, interest so and so, right? And search this kind of keywords. The system should automatically be able to say. Now, what happens is if you create a rule-based mechanism, like if a person is age is so and this so and so, how many rules can you create for your 1 lakh plus products? So you need to have a mechanism where the system automatically identifies all of these traits. Correct? So when somebody has to do like that, you have to make machine to learn these kind of patterns and give suggestions basis any unseen data. So you have an existing data available. Your system has now learned entirely, right? And now, whenever you have a particular person who is new to the system or who is a repeated person, repeated customer, but has not searched for these kind of keywords, you should be able to predict what would be the product that they would end up buying. Right? So that is what we are going to specifically learn when you talk about machine learning. Second, why is machine learning? The core objective of machine learning is to make the system an automated way of understanding certain patterns and predicting something, right? And this prediction can be stock market prediction. This predictions can be basis. Okay, if I give the blood information, like let's say for example, pathological information of a particular patient, you should be able to predict what kind of disease that person is having, right? So if you want to do like that as well, you need to have a proper framework in place where the machine learns by certain set of algorithms and predicts for any unseen data. Then we are going to talk about what is the framework of developing all of these models. Why should you use Python and not other languages like Java, .NET, and all those? Then what is the Python stack? See, Python is a scripting language that is used for doing web applications. Now, how did that come into existence with reference to data science? And second most important thing is, because Python is so vast, don't you think that you require a subset of those things? So if Python has 1 lakh plus packages, do you require all of those packages to be learned? Or is it okay if you learn only those things that are required by data science? Right? Then we will also see about Anaconda platform and introduction to Python. So in today's agenda, we will go through the entire first chapter of the subject and for the textbook. And what we will also do meanwhile is in between, I'll be talking about certain set of use cases and all those basis what Chahat explains. So Chahat, over to you, and I'll mute myself now.
Okay, so I hope my voice is audible.
Yes, it is.
Okay, so today's agenda is as follows: Introduction to machine learning, which would include introduction to analytics and machine learning, why machine learning is used, frameworks for developing machine learning models by Python stack for data science, getting started with Anaconda platform, and an introduction to Python. Let's start with introduction to analytics and machine learning. So, as we all know, artificial intelligence has emerged as one of the most commonly used terminologies with applications across various industry domains. Machine learning, which is a subset of AI, is an important set of algorithms used for solving several businesses and social problems. Analytics is a collection of techniques and tools used for creating value from data. Techniques include concepts such as artificial intelligence, machine learning, deep learning, etc. Artificial intelligence is basically algorithms and systems that exhibit human like intelligence, whereas machine learning is a subset of AI that can learn to perform a task with extracted data or models. Deep learning is a subset of machine learning that imitates the functioning of a human brain
But you have a background
in order
noise.
to solve the problems. The relationship between learning can be visualized from the figure shown in the presentation. So let's talk about machine learning first. What is machine learning? Machine learning is a set of algorithms that have the capability to learn and to perform tasks such as predicting things or classifying things or data efficiently. Machine learning is used in internet search engines, email filters to sort out the spam, websites to make personalized recommendations, banking software to detect unusual transactions, and lots of apps on our phones, such as voice recognition, speech recognition, etc. Machine learning has proven to be one of the most game changing technological advancements in the past decade. In the increasingly competitive corporate world, machine learning is enabling companies to fast track digital transformation and move into an age of automation. Some might even argue that AI or ML is required to stay relevant in some verticals, such as digital payment, fraud detection in bankings, or product recommendations. As with any method, there are different ways to train machine learning algorithms, each with their own advantages and disadvantages. To understand the pros and cons of each type of machine learning, we must first look at what kind of data they ingest. In machine learning, there are two kinds of data, labeled data and unlabeled data. Labeled data has both the input and output parameters in a completely machine readable pattern, but requires a lot of human labor to label the data to begin with. Whereas the unlabeled data only has one or none of the parameters in the machine readable form. This negates the need of human labor but requires more complex solutions. Now let's have a look at the four categories of machine learning algorithms: supervised learning, unsupervised learning, reinforcement learning, and evolutionary learning. Supervised learning is the type of machine learning in which machines are trained using well labeled training data, and on the basis of that data, machines predict the output. Output data to the machine learning model. The aim of the supervised learning algorithm is to find a mapping function to map the input variable, let's say x, with the output variable y. In real world, supervised learning can be used for risk assessment, image classification, fraud detection, spam filtering, etc. So let's have a look at an example. Suppose we have a dataset of different types of shapes, which includes squares, rectangles, triangles, polygons, etc. Model for each step. In order to do that, we will follow the following steps. If the given shape has four sides and all the sides are equal, then it will be labeled as a square. If the given shape has three sides, it will be labeled as a triangle. If a given shape has six equal sides, then it will be labeled as a hexagon. Now, after training, we test our model using the test set, and the task of the model is to identify the shape. The machine is already trained on all types of shapes, and when it finds a new shape, it classifies the shape on the basis of a number of sides and then predicts the output. So, the basic steps involved in supervised learning can be said to be to determine the type of training data set. Then we collect and gather the label training data set. We then split the training data set into training and testing as well as validation data set. We determine the input features of the training data set, which should have enough knowledge so that the model can accurately predict the output. Then we determine the suitable algorithm for the model. Finally, we execute the algorithm on the training data set. We then evaluate the accuracy of the model by providing it the testing set. Sometimes we need validation sets as the control parameters, which are basically the subset of the training data set. If the model predicts the correct output, this means that our model is very accurate. Now let's have a look at unsupervised learning. Unsupervised learning is the machine learning technique in which models are not supervised using training data sets.
Before we start this, right? So I wanted to add few points with reference to supervised learning. right? So most important thing in supervised learning is at the end of the day, you are trying to predict something. It can be a stock market price, it can be the amount of the quality of iron ore that you are getting into a blast furnace, or it can be the volume of water that is going through a pipe, right? So there can be n number of use cases where I am going to predict something, right? Similarly, what is the probability that a particular person, right, will end up having the particular disease, right? So there can be n number of use cases where I do prediction. So when I do prediction, there are two types of predictions. Either I predict a number or I predict yes or no, maybe kind of thing, right? So I can predict a discrete value, I can predict a continuous value. So in those two cases, most of the things work out. So Mahesh, did you understand what is supervised learning?
Yes, sir.
So can you give one example of supervised learning?
Uh, so classifying an email as spam or genuine email, or
Yeah. So does it come under classification or does it come under regression analysis?
classification.
It comes under classification. Okay. Okay. Let's go ahead. Chahat.
Technique in which models are not supervised using training dataset. Instead, model itself finds the hidden patterns and insights from the given data. It can be compared to learning, which takes place in the human brain while learning new things. Unsupervised learning is a type of machine learning in which models are trained using unlabeled dataset and are allowed to act on that dataset without any supervision. Suppose the unsupervised learning algorithm is given an input dataset containing images of different types of cats and dogs. The algorithm is never trained upon that dataset, which means it does not have any idea about the features of the dataset. The task of the algorithm is to identify image features on their own. So what it will do is perform this task by clustering the image dataset into different groups according to similarities between images. Here we have taken an unlabeled input data, which means it is not categorized and corresponding outputs are also not there. So now this unlabeled input data is fed into the machine learning model in order to train it. Firstly, it will interpret the raw data to find the hidden patterns from the data and then will apply suitable algorithms such as k-means clustering, decision tree, etc. that we will discuss further on. Once it applies the suitable algorithm, the algorithm divides the data objects into different groups according to the similarities and differences between objects. In this case, the similarities and dissimilarities can be the whiskers of a cat or the triangular pointy ears of the cats and such. The nose differences can also be interpreted. The third type of machine learning algorithm is reinforcement learning. Reinforcement learning algorithms can be used in many data sets. There could be uncertainty around both input as well as the output variables. For example, let's consider the case of spelling check in various text editors. If a person types beautiful in Microsoft Word, the spell check will immediately identify if the spelling is correct or not. Whereas if he ends up typing a wrong spelling of beautiful, or let's say replaced the B with a D and made it beautiful, or any incorrect spelling for that matter, then it would specify your mistake and ask you to correct it. Here, the prediction is not a single value but a set of values. We can also define the reinforcement learning as algorithms. You have to take sequential actions to maximize a reward. The fourth option or the fourth type of learning is evolutionary learning. Evolutionary learning algorithms are algorithms that imitate natural evolution to solve a problem technique, such as genetic algorithms and optimizations of colony fall under the category of evolutionary learning algorithms. Now, why do we need or why do we use machine learning? Organizations across the world use several performance measures such as return on investment, market share, customer retention, sales growth, customer satisfaction, and so on for quantifying, monitoring, benchmarking, and improvising their products. Organizations would like to understand the association between the key performance indicators and the factors that have a significant impact on their respective businesses. So, a typical machine learning algorithm uses the following steps. It identifies the problem statement or the opportunity for value creation. It will then identify the source of data and create a data lake. Third step would be pre-processing the data for issues such as missing or incorrect data. It will also generate variables using feature engineering, which we will discuss further, and transform the data if necessary. Divide the datasets into subsets of training and validation datasets. Build the machine learning models and identify the best model using model performance in validation data. Finally, it would implement the solution, decision, or the developed product. Some of the use cases of machine learning we see every day are as follows. In email filtering for spam detection, email detection, phishing email detection, etc. Automotives, vehicle detection and tracking, vehicle motion detection, etc. Scratch detection in vehicle can also be done. In healthcare, blood cancer detection, heart disease detection, brain tumor detection, skin disease detection. In agriculture, for plant disease detection, plant recognition, crop type classification, or even counting fruits. In banking, for fraud account detection and insurance. In industrial, for document digitization, optical character recognition, facial recognition on social media, etc., are also some of the use cases of machine learning. Now, let us discuss the frameworks for developing machine learning models. The framework for machine learning algorithm development can be divided into 5 integral stages. First one being problem and opportunity identification, collection of relevant data, data pre-processing, model building, and model deployment. The success of any ML project will depend on the following activities. First would be feature extraction. Feature extraction is a process of extracting features from different sources. For a given problem, it is important to identify the features or independent variables. Those are nothing but variables which are not dependent on another variable for their existence, or they won't have any effect because of other variables. So, after that, the organization store data captured by them in enterprise resource planning systems, but there is no guarantee that the organization would have identified all the important features while designing. So it is also not possible that the problem being addressed using the algorithm may require data that is not captured by the organization. For example, let's consider a company that is interested in predicting the warranty cost for a vehicle manufactured by them. The number of warranty claims may depend on whether the conditions such as rainfall, humidity, and so on. In many cases, feature extraction itself is an iterative process. The second one is feature engineering. Once the data is made available, an important step is feature engineering. The model developer should now decide how he or she would like to use the data that has been captured by deriving new features from it. So this could include addition of new values by mean, median, mode, etc. The success of any model may depend on feature engineering. Third one is model building and feature selection. During model building, the objective is to identify the model that is more suitable for the given problem context. The selected model may not be always the most accurate model, as accurate model may take more time to compute and even require extensive infrastructures. The final model for deployment will be based on multiple criteria such as accuracy, speed, cost of deployment, etc. So, as a part of model building, we will also understand feature selection, which identifies the important features that have
Sahat, can you go
significant
on the back side,
relationship with the
previous
outcome.
side? Perfect. Okay. So here in this particular thing, right, there are basically 4 to 5 steps that we are looking at. Number one is feature extraction. Very simple example is, let's say you are trying to create a machine learning model to predict, let's say something like COVID-19 in a chest X-ray. Now, if you have a chest X-ray with you, what is the thing that you're going to look at? From a doctor's perspective, what you're going to look at is white patches within that particular image or X-ray. So obviously, if you want your computer or machine to understand and tell, okay, whether that particular person has COVID and what is the extent to which the COVID has spread. So you need to have a mechanism of extracting certain things from that image. Now, what is it that you're going to extract? You're going to extract the color, you're going to extract the texture, you're going to extract the boundaries of the white patches and all that. So when you're trying to extract all of those, what is it that you are going to look at? The most important point there is, because I said, right, color, texture, and all those things. The most important point here is that at the end of the day, whichever technique you use, whichever use case you use, you need to extract features from that particular data that you have. So when you say features, for image, the feature would be color, texture, brightness, all those things. For a use case where you're trying to identify from a given sentence in English, if you're trying to identify whether it is sarcastic in nature, whether it is positive, negative, right? What is it? So if you are trying to extract it from a text, then your features are those set of words which are really important for you. So when you say feature extraction, it is basically the important pointers that distinguishes your information that is present. Right? If you have a normal chest X-ray which doesn't have COVID, the features would be, the value of those features would be different. But the features that are extracted in a non-COVID X-ray and a COVID X-ray is same. Whatever the color, brightness, all those things is same. What is going to differ is the numbers that are there within that. Right? That is feature extraction. When I say feature engineering, you have to identify certain set of features which are really important for you. For example, let's say that you want to take a seat in engineering. What is most important for you? Physics, chemistry, maths. How much marks you have got in Hindi and English doesn't matter, right? So what is important features here in this particular use case? Important feature is physics, chemistry, and maths. Rest of all features are useless. Now, even if the system has extracted 100 features, what is it that is useful for you to solve your problem? That is only 3: physics, chemistry, and maths, right? Then once you talk about model building and feature selection, most important thing, see, when you talk about feature engineering and feature selection, there is a very thin line between both of them. There are a lot of cases where within feature engineering, you do feature selection, identifying the best set of features. When I say model building means that you create a framework or you create a setup where any new data that comes from outside would be processed into this particular system that you have created, and it is going to give you a desired outcome. So let's say the desired outcome is identifying COVID-19 in chest X-rays. So you develop a model using non-COVID images, COVID images, and next time when you bring in a new X-ray of some patient, then it should automatically tell whether it's a COVID patient or that particular person is the non-COVID, right? So these two things, creation of that entire framework and running that framework for an unknown data set, everything comes under model building and implementation. When we talk about deployment, what is deployment? So you created a machine learning model, you created a framework, but how do we use it? So let's say if I basically go ahead and create a mechanism where you will ingest chest X-rays into my app that I have created, and my app is going to tell you whether COVID not COVID. So I need to deploy my model into an application. You cannot just give a Python code to end consumer, right? You are going to give a application. So you have to create an application, deploy the model into a setup where for any given end user who does not know machine learning, he should be able to use or she should be able to use that particular application, right? So model deployment is a very important concept. The reason I added application with model deployment is so that you can visualize that thing. So when you say model deployment, it will be a standalone thing that is available. You will create an application over it. You ingest your chest X-rays into that application. You do not see the model on the front end. What you are going to see is an upload button and a corresponding answer, whether COVID, not COVID. So if you see the model is set up somewhere, it will be set up on a cloud platform or a system or a standalone machine like your laptop. But at the end of the day, if you say deployment, it should be accessible by any front-end application that you have created. Now, till this particular point, anyone has any questions? Mahesh, Kimaya, Tavishi?
No, sir. Got it.
Mahesh, any questions?
No, sir.
Perfect. Let's go ahead.
Let's have a look at the model overview. It contains of 5 stages. The first is problem or opportunity identification. A good machine learning project starts with the ability of the organization to define the problem clearly. Domain knowledge is very important for this. The problem definition should be apt and should address the major challenge faced by the company. The second is collection of data. Once the problem is defined clearly, the project team should identify and collect the relevant data. It is an iterative process since relevant data may not be known in advance, but after it's known, along with the ERP, that is Enterprise Resource Planning, and external sources, a data lake is created which will play a major role in the next process. The next is data pre-processing. So the evidence suggests that the data pre-processing and data preparation should be done with keeping in mind significant factors for any analytics projects. This would include data cleaning, data manipulation, imputation, creation of new variables, etc. Fourth is model building, which aims to find the best model. To avoid overfitting, it is important to create several training and validation data sets for our testing, and also so that we would get a better accuracy. The final step is communication and deployment of data analysis. The primary objective of ML is to come up with actionable items that can be deployed. The communication of the ML algorithm output to the top management and clients plays a crucial role in this. And during the deployment of the model, it could involve developing software solutions, products such as recommendation systems, etc. Now let's discuss why Python is being used for the machine learning as a primary source. So Python is an integrated high-level general purpose programming language. One of the key design philosophy of Python is that it is very readable and very easy to understand. Along with the ease of use and high productivity, it has become one of the most popular languages used for data science. Python has an amazing ecosystem and is excellent for developing prototypes quickly. Unlike R, it is not built only for data analytics, but it is a general purpose. It can be used to build web applications, enterprise applications, and is very easy to integrate with existing systems as well. Let's talk about the stack for data science. Most of the computations for our notebooks will be done on Anaconda. Anaconda is a distribution of the Python and R programming languages for scientific computing. It aims to simply specify package management and deployment. It is very good for beginners as well as expert level people. So there are two commands written on the screen. The first is to install py.plus. Py.plus is an improved version of the old pydot project that provides a Python interface for graphics.language. It is very easy to use and would help us to use the utilities compatible with Python 2 as well as Python 3. TensorFlow is an open source software library for high performance numerical computations. It is a very flexible architecture which also allows easy deployment of computations across CPUs, GPUs, DPUs, and from desktops to clusters of servers to mobiles and even edge devices. So when you have a very high computational requirements, but you don't have a laptop or computer that could accommodate those requirements, these are some of the libraries which can be downloaded and can be used directly through Anaconda. Let's talk a little bit about the types of data. At the highest level, there are two kinds of data that exist, quantitative and qualitative. There are two types of quantitative data, that is continuous and discrete. Discrete data is a count that can't be made more precise. For instance, the number of children or adults or pets in your family is a discrete data because you're counting them as a whole. They are indivisible entities. Whereas continuous data would include height of a person or the age of a person, which is constantly growing. It could be divided or reduced to finer and finer levels. Categorical data. It has two main types, nominal values, which represent discrete units and are used to label variables that have no quantity value. Nominal data has no order, whereas ordinal values represent discrete and ordered units. It is therefore nearly the same as nominal except in its ordering matter. Some of the examples of ordinal would be movie ratings on a scale of 1 to 5, and categorical would be gender of a person or yes or no answers for any data. Talking about the data types, Python has 5 standard data types, which is numbers, strings, lists, tuples, and dictionaries. The first is numeric values. In Python, numeric data represent the data which has any numeric value. Numeric value can be integer, floating number, or even complex numbers. These are defined as int, float, and complex classes in Python. Integers includes positive or negative whole numbers. It is the same as mathematical units, but it can be used in Python very easily. Float value is represented by the class named float. It is a real number with floating point representations. It is specified by a decimal point. As for the complex numbers, it is represented by complex class and is specified as real part plus imaginary part. For example, -2 plus 3j. There is a function called type which can be used to determine the type of the data type. Second is strings. Strings are arrays of bytes representing Unicode characters. A string is a collection of one or more characters put in a single quotation, double quotation, or even a triple quotation. In Python, there is no character data type. A character is basically a string of length 1. It is represented by the class str. The third one is lists. Lists are just like arrays declared in other languages, which is an ordered collection of data. It is very flexible as the items in a list do not need to be of the same type. The fourth is tuples. A tuple is also an ordered collection of Python objects. The only difference between tuple and the list is that tuples are immutable. Immutable means that tuples cannot be modified or after they are created. It is represented by the class tuple, and they are created by placing a sequence of values separated by comma or with or without the use of parentheses for grouping the sequence. Tuples can contain a number of elements of any data types like strings, integers, lists, etc. Tuples can also be created with a single element. Having one element in the parenthesis is not sufficient. There must be a trailing comma to make it a tuple. There is another data type called set. Set is an unordered collection of data type that is iterable, mutable, and has no duplicate elements. The order of elements in a set is undefined, though it may consist of various elements. The last one would be dictionary. Dictionary is an unordered collection of data values used to store data values like a map, which, unlike other data types that hold only single value, this actually holds key value pairs. Key value pair is provided in the dictionary to make it more optimized and to assign values. For each key value pair in a dictionary, that it has to be separated by a colon, whereas each key is separated by a comma. Dictionary keys are case sensitive. Same name but different cases of keys will be treated as distinct. There are some of the examples shown on the screen. Now, let's have a look at some of the common libraries available for data analysis. The first one is NumPy. NumPy is basically used for mathematical computations. NumPy is a fundamental package for scientific computing involving large arrays and matrices. It provides useful mathematical computation capabilities. Pandas is used for data structure operations or data frames. It provides high performance, easy to use data structures, which are called as data frames, for exploration and analysis. Data frames are the key data structures that feed into most of the statistical and machine learning models. There is also Matplotlib available for visualization, SciPy, which contains modules for optimization and computations. It is used mainly for statistical computations. Then there's stats models, which provides classes and functions of various statistical analysis. In machine learning, there are often three values that interest us. They can be classified as mean, median, and mode. Mean is the average value, median is the midpoint value, and mode is the most common value. To calculate these, we can directly use the inbuilt methods available in Python, which is mean, median, and mode. We will now look at some of the hands-on applications of the things we have discussed so far.
So shall I continue with the notebook?
So any question anyone has?
No, sir.
Okay, now can each one of you in like 2-3 lines tell me what did you understand from this entire exercise or discussion that we had?
Sir, may I?
Yeah, please.
Yeah, the very initial part regarding we had gone through is why machine learning, what types of different machine learning, different types of machine learning, then what exactly they mean, that is supervised learning, unsupervised, reinforcement, and evaluation. Then what are the most important steps required to execute any model in machine learning, that is identification of the data set, then collection, pre-processing the data set, then building the model, and then deploying the model. Also, the most important feature is extraction of important features and making feature engineering process. Also, we have studied why there is need of Python, or what is the importance of Python in machine learning, how flexible, how readable this language and compatible it is for developing the models in machine learning. Also, we have gone through the one of the tool called as Anaconda, where we can execute our models. We can deploy our models using Python language, its inbuilt functionalities. Then what are different data types in Python? Yes.
Got it.